Okay, today let's talk about the second order linear differential equation. And with this, we must know that we talk about the complete solution. The complete solution, to which it is divided into two parts. We have the complementary, and the complementary is given as, in order to obtain the complementary function. In order to obtain the complementary function, we have to solve the equation a d square y all over dx square plus b dy all over dx plus cy equals to 0. As we go, we are going to understand this more better. Then we have the particular function. We have the particular function, to which it is obtained by substituting into this equation. So you have something like ad square y all over dx square plus b dy all over dx plus cy equals to f of x. So in order to get the complete solution, in order to get this complete solution, it is given as y equals to yc plus yp, where yc stands for the complementary function and yp the particular integral. This is the particular integral. You can also call it the particular function, but it's a particular integral. So in order to determine the complementary function, when this equation is given, we need to form an auxiliary equation. An auxiliary equation. You have to form an auxiliary equation such as you see where you have this, so that you are m, you can say m, let m be equals to dy all over dx, so that when this has been given, you can say this will be m square plus b m plus you can say y or c plus c equals to 0. So you can, from here now, you'll be able to determine your yc. So you'll be able to determine yc if this is like, if it's like that. Then you should not forget that in this equation that we have formed here, there can be of three possibilities. The first one, have the real and different roots. You have the real and different roots, which means that if your m1, you can say this is m1, something like that. So your m1 will be equals, can be, let's say 1, and your m2 will be equals to maybe 3. So you see that these are not the same. So m1 and m2, they have two different values. So it's known as real and different roots. So if you factorize this and you find the value for m1 not equals to that of m2, it means you are dealing with a real and different root. So if the solution will be given as y equals to ae to the power m1 x plus be to the power m2 x. Yeah. So let's talk about the second one, which is the real and equal roots. Real and equal roots, which we can say it means that m1, if let's say m1 is 2, your m2 will be equals to 2. So this will be given as y equals to ae to the power mx, as a m1x or m, and just see that equal, plus b x e to the power mx. But this you can y, since this and this is common, can take it out of the bracket. It will be e to the power mx into a plus b x. Then the third one is the complex root. With the complex root, you have complex, like from complex numbers, which after you factorize this, you have a complex number, which can be, say, m1 will be equals to a plus jb, and m2 equals to maybe a minus jb, or jc or jb. Yeah. So your formula, it will be given as y equals to a e to the power a plus jb, or that x plus b e to the power a minus jb x. And then so from this, you say from the theory of complex numbers, however, they express this in the form, so you can express this from the theory of complex number, you can express it as y equals to e to the power ax into a cos bx plus b sine bx. So if you can remember all of this, then you'll be able to approach on how to determine the complementary function.